Hello everyone, and welcome to day 3 of our 150 Days Bug Bounty Training Challenge, Zero to Hunter series. I'm Sagar Majumdar, and I'm excited to guide you through today's session. Today, we'll explore what an API is and understand the crucial role it plays in the tech world. We'll also give you a sneak peek into how APIs are essential for modern applications and security testing. So, let's get started and dive into the fascinating world of APIs. Let's dive into the core idea of this slide, understanding APIs, which are often called the digital connectors. Essentially, APIs are the bridges that allow different software systems to communicate and work together seamlessly. This presentation aims to give you a clear picture of what APIs are, how they function, and why they are so strategically important in today's digital world. We'll explore their basic principles, architecture, and how they enable innovation and efficiency across various industries. Remember, APIs are the backbone of modern software integration, making complex digital ecosystems possible. And by the way, API stands for Application Programming Interface. It's the technical term, but what it really means is a set of rules that lets one software access features or data from another. Understanding APIs is fundamental to grasping how modern applications connect and interact. So let's talk about what an API actually is. An API, or Application Programming Interface, is essentially a connection between computers or between computer programs. Think of it as a software interface that provides services to other applications. It's like a translator or a middleman that helps two different software systems understand each other and work together smoothly. The main function of an API is to act as this middleman. It enables these programs to communicate, share data, and perform actions in a way that's consistent and standardized. This means they don't have to understand each other's complex internal code. They just need to speak the same language through the API. And this is where the purpose becomes really clear. By using APIs, developers don't need to dive into the nitty-gritty details of how a service's underlying code or infrastructure works. Instead, they can focus on building features and functionalities without getting bogged down by complexity. In the context of our overall theme, understanding APIs is fundamental because they are the backbone of modern software integration. They enable different systems to connect, collaborate, and deliver seamless experiences. So, grasping what an API does and how it functions is a key step in moving from basic knowledge to becoming a more proficient developer or tech enthusiast. Let's take a closer look at the client-server model. At its core, this model describes how devices communicate over a network. First, we have the client. This is the device or application that initiates communication. It could be a mobile app, a web browser, or even another server. The client makes a request when it needs a service or content. Next, we have the server. The server's role is to receive that request and fulfill it. Servers can be specialized based on the services they provide, like a web server that delivers web pages or a file server that manages files. It's responsible for processing requests and returning the appropriate response. Now, connecting these two is the API, or Application Programming Interface. Think of the API as a kind of middleman or translator. It ensures that the communication between client and server happens smoothly and predictably. To make it more relatable, imagine the API as a waiter in a restaurant. The waiter takes your order, your request, and delivers it to the kitchen, which is the server. Then, the waiter brings back the food, which is the server's response. This analogy highlights how the API facilitates clear, structured communication. This model is fundamental because it underpins how modern applications function, enabling seamless interactions between different systems. It's a perfect example of how structured communication is vital in building reliable, scalable networks. And as we continue, we'll see how this concept plays a crucial role in developing robust software architectures. All right, let's dive into the anatomy of an API request and response. First, we have the URL and endpoints. Think of this as the address of the server and the specific paths that point to the resources we want to access. It's like giving someone a precise street address so they can find what they're looking for. Next, we have HTTP methods. These are the actions we want to perform, like get to retrieve data, post to create new data, PUT or patch to update existing data, and delete to remove data. Each method has its specific purpose, and choosing the right one is crucial for how the server handles your request. Then there are headers and parameters. Headers are like the request's metadata. They can include authentication tokens, data format preferences, or other specific details. Parameters, on the other hand, are used to refine or specify the request further, like filtering results or specifying pagination. Finally, we have the response. This is what the server sends back after processing your request. It includes status codes that tell you if everything went well or if there was an issue, headers that provide additional context, and the data payload, which is usually in JSON format. This payload contains the actual data you asked for or information about the action you performed. Connecting this to our overall theme of understanding how APIs work, mastering this anatomy helps us communicate effectively with servers and build seamless integrations. It's the foundation for making your applications more dynamic and responsive. So let's take a closer look at this case study involving the Agify EO API. On this slide, we see an example of a request. We're making a GET request to the API endpoint, passing in the name Michael as a parameter. The URL looks like this: https://API, Agify, EO, name equals Michael. Now the response example shows the kind of data we get back. It returns a JSON object with 3 key pieces of information. First, the count, which tells us how many data points were used to make this prediction, in this case, over 482,000. Next, the name itself, which confirms the input, Michael. And finally, the age, which in this example is 52. So, based on the data, the API predicts that someone named Michael is likely around 52 years old. What makes this API really useful is its simplicity. It takes a name as input and provides a predicted age, along with the context of how many data points support that prediction. It handles various inputs effectively, and it also offers additional details like rate-limiting headers. These headers help manage how much we can use the API at once, ensuring it stays fast and reliable for everyone. Connecting this to the broader theme of our presentation, this example demonstrates how APIs can deliver powerful, data-driven insights in a straightforward way. It's a perfect example of how APIs can be integrated into applications to enhance functionality, making them more intelligent and responsive to user needs. Let's take a closer look at some of the key API architectural styles that shape how we build and connect modern applications. First, we have REST. REST is all about data-driven, stateless architecture, which means each request from the client to the server is independent and contains all the information needed to process it. It uses standard HTTP methods, making it incredibly flexible and scalable. That's why REST has become the de facto standard for most modern web applications. Next up is SOAP. SOAP is a more rigid structured protocol that uses XML for messaging. It's function-driven, which means it focuses on specific operations or functions. While it's considered somewhat legacy today, SOAP remains critical in environments where reliability and strict security are paramount, such as in financial or enterprise systems. Then we have GraphQL, which is a bit different. It's a client-driven query language that allows developers to request exactly the data they need, no more, no less. This precision helps minimize overfetching, reducing network overhead and improving performance, especially in complex applications. What's really interesting is how these styles reflect an evolution, from SOAP's server-driven, structured approach to REST's more flexible, stateless model, and finally to GraphQL's client-driven, highly efficient querying. This shift highlights a broader trend toward giving more control to clients, optimizing for performance and flexibility in our applications. And that's a quick overview of API architectural styles, each with its strengths and ideal use cases, shaping how we build scalable, reliable, and efficient systems today. Now, let's take a look at APIs across different industries and see how they're transforming the way we do business and interact with technology. In the e-commerce and payment space, companies like PayPal and Stripe provide APIs that make it incredibly easy to process secure transactions. This means businesses don't have to build their own payment systems from scratch, saving time and reducing complexity. Moving to social media and communication, APIs from platforms like Twitter and Slack enable third-party applications to extend their core functionality. This opens up a lot of possibilities for customization, automation, and integrating social features into other tools we use daily. And then, in mapping and travel, Google Maps APIs are crucial for powering location-based services. Whether you're booking a trip or finding your way around a city, these APIs help aggregate data from multiple sources, like airlines and hotels, making travel planning more seamless and integrated. All of these examples show how APIs serve as essential connectors across industries, enabling innovation and efficiency. They're really the backbone of the interconnected digital world we're building today. Now, let's talk about API security and some critical considerations. First, it's important to distinguish between authentication and authorization. Authentication is all about verifying who is making the request, while authorization determines what they are allowed to access once their identity is confirmed. Both are essential for securing APIs effectively. When it comes to common authentication methods, there are a few key ones to keep in mind. API keys are straightforward and easy to implement, but they can be vulnerable if exposed or leaked. OAuth 2 is a more robust, token-based system that provides secure access, especially useful for delegated permissions. And then there's JWT, or JSON web tokens, which carry signed payloads containing user information, making them convenient for stateless authentication. Moving on to best practices, always ensure your communication is secure by using HTTPS. It encrypts data in transit and protects against eavesdropping. Input validation is crucial to prevent malicious data from causing harm or exploiting vulnerabilities. Rate limiting helps prevent abuse by controlling how many requests a client can make in a given time frame. And API gateways serve as a centralized point to enforce security policies, manage traffic, and monitor API usage. All these measures are vital pieces of the puzzle in building secure, reliable APIs. As we continue with this series, remember that securing your APIs isn't just a technical necessity. It's fundamental to maintaining trust and integrity in your applications. Let's take a closer look at the API economy and how it impacts businesses today. First, APIs significantly reduce development costs. Instead of building every function from scratch, companies can leverage ready-made APIs that provide the necessary features right out of the box. This not only saves time, but also resources. Next, we see that APIs accelerate innovation. By focusing on their core competencies and integrating existing APIs, companies can develop new features and services much faster. This rapid development cycle enables them to stay ahead in competitive markets. And finally, APIs open up new revenue streams. Businesses can monetize their APIs through tiered access based on usage, creating scalable and sustainable income sources. At its core, APIs enable a modular approach. Companies can assemble services from specialized, reusable components. This modularity fosters accelerated innovation and supports the creation of new business models, making the overall ecosystem more dynamic and flexible. This interconnected API ecosystem is a key driver of digital transformation and growth, aligning perfectly with our theme of moving from zero to hunter in the digital age. Now, looking ahead to future trends and the strategic importance of APIs, let's explore some key developments. First, microservices are transforming how we build applications. Instead of creating large, monolithic systems, we're breaking them down into smaller, independent API-driven services that can be developed, deployed, and maintained more efficiently. This modular approach offers greater flexibility and scalability. Next, we have composite APIs. These allow us to combine multiple services into a single call, which significantly reduces network overhead and improves performance. Instead of making several requests, clients can get all the necessary data in one streamlined operation. Then there's the rise of management platforms. These platforms play a crucial role in centralizing security, rate limiting, and versioning across entire API ecosystems. They help us maintain control, ensure security, and manage updates effectively as our systems grow more complex. Finally, it's important to see APIs not just as technical tools, but as the strategic foundation of a modern digital ecosystem. They enable modularity, efficiency, and connectivity, essential qualities for innovation and agility in today's digital landscape. So, as we look to the future, embracing these trends will be key to building resilient, scalable, and interconnected systems. This is how APIs continue to shape the evolution of technology and business strategies.